All right, well, the still waiting its parts, obviously. So today we're going to do something a little bit different. We are going to work on something smaller. So um, recently there was been discussion about some cooling, things of that nature, and obviously cooling is going to be a concern when it comes to building a big block or big bore setup. Big block, big bore. I know some of the RC 390 guys run into cooling problems and stuff like that too. So I talked to a person a while back, and I haven't done anything with it, but I have discussed this before. The goal today is going to be to see what it's going to take to install the 450 EX impeller, another thumper as well. But the shaft itself is exactly the same as the 390 as far as where it mounts. Now, big difference is diameter wise, it's a lot different. This one's actually smaller, but these fins are a lot bigger in comparison. And it actually recesses into it, at least it's supposed to. So we're gonna take a look at that real fast. So step one's gonna be pulling off the old cover, or the cover I should say, and then see if we can extract the old impeller without any crazy issues or anything like that. The goal is going to be to see if we can remove it without breaking it if possible, and then see exactly what it's going to take. I'm guessing that we're going to have to trim these down. This sits pretty high up here is what it looks like, so I don't know if we have. I mean, it looks pretty big, but no, we'll see. So let's get set up real fast. We'll get the camera pointed in the right direction, and then let's hit the bolts off. Luckily, there's not that many. Looks like I can see 5. So let's see. All right, so pretty standard. These are the typical 8 mils that you see pretty much everywhere else. So nothing too crazy. I think these bolts are shorter, so they're pretty easy to identify the differences between them. Yeah, they're shorter. So if you look, definitely a difference between the standard case size. And it looks like all of these are the exact same size. I don't think you can mix them up. Okay, ignore that one. They're all the same size. So, drain port here. I've already drained mine, so there shouldn't be anything in there. But 1, 2, 3, 4, 5. And if I remember correctly, I want to say there's some location pins on here as well. So these two are kind of the lift points. So if you need to use a screwdriver, you can put it in there to pry it off. Let's see if I can wiggle it off. Okay. Boom. That's the inside. Now, as you can see here, we've got a inlet that comes in from the radiator. So it comes in this direction. Comes in through here. I'm assuming this right here is designed to help divert it and straighten the water before it goes in. Now, if we take a look, this is our water pump impeller. Let's line this up, and you can see that this one is definitely bigger diameter wise, but the blades on this are significantly bigger. And they actually, if you look, we have our cover here. These will actually, it recesses in just like this. Obviously you don't want direct contact, and then I don't know how well it can show on the camera. You can kind of see. Let's see. diameter wise, it's pretty perfect, to be honest. So we'll see. Now there's a locking nut here. That looks like a 9mm. And then what we're seeing is this will rotate this way, and the water will come in through here. It swirls around through here, up and around, and then makes a cut into the block like that. So what I'm kind of wondering about is, since I'm already going to be doing a bunch of work, this is technically smooth considering it's casting. So I want to take this off, and I want to see if I can smooth it out even more. I've polished aluminum in the past. Inside of this is pretty smooth, so I don't see anything crazy. I could probably knife blade this out some more, but if that breaks off and gets lodged inside of there, bad idea. And I doubt there's going to be any huge gains from it. But this part, I feel like I can smooth this part out, and then this transition here, there's a big hump here. And I feel like if I go through, take out some material here in this area, I can probably smoothen out that transition a little bit. So I think while we're at this, we're going to go ahead and take a look at this and see if we can address that in some kind of way, because improving cooling is always going to be great. And I can see inside of here, you might be able to hear this. So in here, yeah, there are definitely some casting lines in here. That's definitely going to affect flow rate too. So we're going to try to clean this transition, and then we're going to try to clean that casting line up too, while working on this as well. So let's see what it takes to get that off real fast. Is that a 10? Seems kind of loose. Maybe it's a 9. Let's see, do I have a 9 right quick? Oh, I guess it is a 10. How much of a pain will this be? Okay, that was easy. 10mm locking nut. There's a spacer, and there's some corrosion. Just a little bit. Oh, nope, that's not corrosion. I think that is blue Loctite. All right, we'll grab something real fast. All right, let's see. How much of a pain is this going to be? The last time I remember trying to do this, it was a bit of a nightmare. In fact, I actually ended up just kind of giving up a little bit, and I actually ended up breaking the impeller because the impeller is made of plastic. Let's see if we can get this out of here without causing... Oh man, yeah, it's really... I remember exactly why this happened last time. I might have to use more precision screwdriver to get in there. Okay, let's see if I can use a thinner blade. Okay, we got something started. I remember this not being easy. Okay. Nope. Oh, we're making it happen, people. All right, that's the ticket. So, get it started on top, and then I use that to allow me to get one in. Once I was able to push it in, I took my fingers on the side, and then I just rotated back and forth while inserting my screwdriver in, and that allowed it to start coming off. Now let me see if I can use a thicker one. Oh yeah. Now I'm using this to do a twisting to give it some leverage. There we go. All right. A little bit of scuffing there, no big deal. Okay, there's the end of it. Now, I'm gonna clean this end up here, but this right here is right inside of here. These are the two pumps that you would, or pump seals that you would replace. There's two inside of here. You have a collar here that needs to come out. Let's see. All right, I can't do it with my fingers, but there's a collar here, snap ring pliers that comes out, and there's two seals inside of this. It is not easy to be able to pull that out. In fact, I remember when I did it, I want to say I ended up using like a screw on the inner one in order to actually extract that thing out of there. So as you can see, this goes all the way around. Our goal is to clean this surface up and try putting this other one in. As you can see, we'll hold these back to back. Definitely a difference in diameter, but look at the blade. The blades themselves are significantly different. So I'm going to see if I can hold this up for a second and get an idea. It looks like it's going to be a pretty tight fit. I wonder how easy this would be kind of put on here and see. I also don't want to put it on there and then it gets stuck without being able to do any work. Oh yeah, meant to show you. So on the end here, it's kind of hard to see on this. The end here is shaped exactly like this. And you can see, it's kind of hard to tell, but the shaft, it's flat spotted here, which is perfect for this. So let's just take a look. Maybe we don't do the full commit. We just kind of see, oh, you know what? Oh no, we're gonna full commit. Let's see. That fits inside. And how are we fitting overall? Okay. All right. So it looks like we definitely need some clearancing. Let me check something here. About 15.5 millimeters. So yeah, I think the ticket is going to be to start shaving down a little bit and then see if we can maintain. I'd like to redo this profile. Keep the blades that go in and trim it down kind of like that. That'll allow it to actually fit inside of the pump fully. Let's see if I can get this line back up. Okay. Okay, yeah, we're sitting on it Let's see here. How much do we need to trim? Based off of what I'm seeing here, oh, 5 mils. Okay. Come on. All right, cool. So we're definitely gonna have to shave this down. I think I'm gonna go lower. I think what we'll do is we're gonna start maybe about 2 mil from here and see what our profile looks like after that. And we're just gonna do this slowly. We'll slowly start trimming it down, and that's gonna give us an idea how far back we need to go. I think the main problem here is when we look at this side is convexed inward, and so it allows it to sit flat, whereas this one isn't as convexed, and so there's a protrusion here because of this. So what I think I'm going to do is I'm going to look at this part right here first. Okay, this seems a bit challenging to be able to, I think that's hardened steel. I don't know how easy that's going to be to drill out, but I do have this side. This already has a recessed area. I think it would be easier if we drilled this side out instead. So I'm going to drill this side out. That'll allow us to get it a lot closer. And I don't want it to ride all the way against it because obviously it is aluminum. And that'll allow it to push further in. We don't have to trim as much of these fins. And then we can take advantage of this unit as a whole. And then in the event that this doesn't work out, we'll still have this, and we can always revert back to our stock setup. So, yeah, I think we're going to work on modifying this first, and we'll pick this back up once I've got this sorted out. So, more to follow on this. We shall see shortly. Went through and cleaned up this little part. A little bit too much clearance, but this had an outer lip, so I used some sandpaper and sanded this part down. So what I'm going to do now is we're going to test fit this and see what kind of a gap we're looking at. And then after that, maybe put the original one on, measure the gap, see if we can get a good idea of exactly what we have to do for these fins. All right, so we've got our shaft here. We got our freshly modified one, and let's go ahead and slip on the collar. Okay, Now I'm going to go ahead and snug this up. Presuming, here we go. Okay, let's see. Just gonna go straight bolt on there for now. And we're just gonna give it a little bit of a crank. And from there, we'll see with what clearances we're looking at. Let's see. All right, let's do a 0.005. Oh, okay. Got some good clearance on one side. Okay, well, maybe if I smooth it out, that's like a 120 grit, that is what I used. Maybe that'll be enough to smooth it out. But it looks like it's not contacting all the way around. That's the important part. So let's have a look. What does the gap look like on the other one? Hopefully this thing isn't a pain when we go to reinstall it. And it doesn't get stuck on there. Here's the old one. Now just to show, a little bit of side to side here, okay, unbolted, and then let's see, same with here, about the same amount. So let's get this. Oh, is that the? Oh, there it goes. Okay, so that is in place. Put that on, and we're gonna put this on, and then we're gonna tighten it down. We're gonna see what factory clearances we're working with here. Oh, okay. I would say it's similar. It feels about the same. If anything, let's see. It might be just ever so slightly looser. This is a thicker shim. Yeah. So it's very close. 1 point or 0.5 or 0.152 millimeter is what we're looking like. And what I measured with the aluminum one was 0.127 millimeter. So, not that big of a difference. Maybe when I go through, smooth out the base of this, it'll give us a little bit more of a gap that we're looking for. Now, one thing to note is that the mounting point where this bolt or nut goes and where the shaft goes on here is taller. So I'll likely not run this spacer because of that, but this overall unit is much taller as well. So let's see if they can snag this thing out of here without it being too much of a pain. And it is. All right, well, you've seen this part before, so we'll come back in a second. All right, got that all smoothed out now. We're gonna take a look and see how does this fit. Oh. Oh, that sounds pretty good. Now let's go ahead and give this a tighten. I'm wondering, I don't remember if this is the original lock washer or if I added that. I don't remember, it seems kind of tall. Okay, a little bit of a snug up there. Now let's take a look and see. So this is 0.06, okay. Just as I suspected. So after we smooth this out, this now has about the same clearance as the original one. Now we can actually go through and rotate this and look and see how it looks. Oh no! That's what I get for precariously balancing this. Maybe at some point I'll build a an actual stand or a case or something that actually mounts to this, and then it'll fix those problems for me. Okay, let's rotate some more. Okay. Well, from what I can see, I would say that looks pretty good. So now that we have this thing technically mounted in the area that it needs to be, close to within spec, there's other considerations, right? Obviously, this is likely not going to fit. So we can probably easily surmise that. Let's see. Okay. Here we are. We can probably tell right at the bat that the depth of this casing right here, it's not going to really allow for the amount of fin space that we have here. Now, the good thing is that internally, these blades will fit within here, but this convex section, right, we're going to have to contour these blades to fit, as well as make sure that these blades fit in this section here. So we're just going to do a general measurement. Yeah, we'll do it right about there. So about 6.9 millimeters is what we're looking like. And then, so if we're looking at 6.9, I think what's going to end up happening is a good portion of these blades will definitely be trimmed. We're going to have to do something to try to maintain some of this profile that we have here. However, the advantage is going to be the center portion of this blade sticking inward. Whereas if you look here, it kind of maxes out right where that convex part is, right? Whereas these blades are going protruding inward. So we need, in order for this to be effective at any capacity, we need to kind of follow the design of how these fins are set up in order for it to actually protrude inward and have some kind of effect to it. So we're definitely going to trim these down. These are definitely going to be chopped a fair amount to kind of match what's on here in order for it to fit. But again, the advantage is going to be that inside section that protrudes into the actual cavity of the pump itself. So I'm going to have to pull this off again, of course. And then from there, we're going to do some measuring and figure out how we're going to trim these blades to make it match and fit the case itself. So that's going to take a little bit of work, and I think I'm going to go ahead and get this removed now. Took some measurements off of this. I was trying to decide if I wanted to go off of the original design, where it is, I guess, much higher on this side. But I think the reason why it's designed that way is because of the original water case and some of the restrictions with that. So what I think I'm going to do is, rather than doing something similar to this, I'm just going to maintain this. I kind of went through and took some initial measurements and scribed some lines on here, and just so happens that one of these Dremel rules is basically that exact amount. So I pretty much just need to go straight down on each one of these to take some off, and I may end up taking some off of the top here. It just depends on, you know, how it looks in the water pump. I don't want these too long, because if it's too long, it might cause some weird problems. But for the time being, I'm going to try to see how this works out and trim it down some. So let me put some glasses on real quick. All right, let's see. Oh yeah, that'll do it right there. So we are below the pump now, which is good. We got these fins down as far as we need to. And now we just have to determine about cutting these back. Let's see. Maybe we won't. I don't know. So I'm going to clean these up, and then I'm going to get this thing put together, and then we're going to rotate it and let's see if we have any clearance issues. Okay, there it is once again installed. Rotating, no problem. Now we're going to see if we can pop this cover on. What I'm going to do at some point, let's put some die chem on here, rotate it, and just see if there's any areas where I'm not tracking in terms of fitment and clearance issues. So let's see here. It's a bit of a pain because I have a bracket right here, but I think I can get this squeezed in. So let's see. That was not a nice sound. Okay. All right. we are installed. Let's rotate it. I don't hear any noises. Okay. Let's see. I wonder if I can get an interior shot and show you a little bit better. You know what? I'm going to hold the camera. All right. Hopefully you can see it. It's kind of challenging. Looks like everything's going nice and smooth. Oh, Rod's not happy. So as you can see, they do protrude into housing. So I guess with that being said, I'm going to end it here. Got a little bit of a mess to clean up. Technically installed. I have no means of testing it. I think what I'm going to do is I'm going to take both of them, see if I can get it mounted to a shaft, maybe like on a Dremel or something like that, and some water to kind of see how it does with water. Sounds stupid, but I really don't have any other means of testing it. I'm assuming purely based on the amount of, I guess, volume for fins, that it's going to be significantly higher and increased flow rate. I think I should trim the fins back a little bit. I'm thinking maybe I don't want them to protrude so much into it because I don't want it to create some issues with, you know, I guess creating turbulence. I'm not really sure. I don't know, stuff. Whoever, I mean, I saw online that this was supposed to be a kind of a straightforward, like direct swap with a little bit of modification, but I can tell you that is not the case. We had to do a fairly decent amount of modification in order to make that work. So for those of you that are out there, let me know what you think. Should I keep the blade length overall, or should I trim it down maybe 2 or 3 millimeters off the top? I'm kind of going towards maybe potentially trimming it a little bit, but I kind of want to see what you guys think. But it does fit pretty well after doing some modification, and I'm pretty happy with the result. It is smaller diameter, but I think it's going to make up for it in terms of the pure amount of fins that are available in terms of the fin height itself. So in it being smaller diameter, I don't think it'll be necessarily a bad thing. I don't know. I guess we're gonna find out together. So the good thing is that I was able to get this off, like I said, without damaging it, my original. So if we are not able to get the proper cooling that we need, we're just gonna put this one back on. No harm, no foul. It'll be a quick and easy swap. So that's all I got. So I am really curious and interested to see what you guys think about the fin height thing. So please drop me a comment below. Let me know if I should trim it down, or if you think I should trim it down, or if I should just continue and keep it at the height that it is. So that's it for now, and yeah, we'll see you in the next one.